Hello and welcome back to our channel. Today we are diving deep into the world of artificial intelligence, specifically focusing on retrieval augmented generation or RAG. Whether you are a tech enthusiast, a student, or a professional in the AI field, this video will give you a comprehensive understanding of RAG, its working, pros and cons, and some real world examples. So let's get started. But before we move on, let us take a look at the topics that we will be covering in this video. Firstly, we will try to understand what is RAG. Then we will take a look at the traditional methods in NLP. The third topic is best of both worlds, where we will discuss how these traditional methods give rise to RAG. And then we will try to understand how does RAG work. We will try to understand this mechanism. Then we will take a look at the advantages followed by its disadvantages. And then lastly, we'll discuss some real-world use cases of RAG. So let us start with the first topic. What is Retrieval-Augmented Generation or RAG in short? So it is a novel approach in the field of natural language processing that combines retrieval-based and generation-based methods to improve the quality and relevance of generated text. We can try to understand this with the help of this diagram. So in order for RAG to work, you need to have a knowledge base. Knowledge base is nothing but your data set. Once it's there in the picture, when a user makes a query, initially the relevant information is retrieved from this knowledge base or your database. And when you have that relevant information from that particular database, which is again pertaining to the user query, then the generation based aspect is applied to the retrieved information in order to create a better response that is then sent out as output to the user. So this is the gist of how RAG actually works, and we will discuss this at length in this video. So RAG combines retrieval of factual information with creative generation of text, and it aims to produce responses that are both contextually relevant and factually accurate. So the factual aspect of it is taken care of by the retrieval based method here, and the contextually relevant aspect of it is taken care of by the generative or generation based techniques. So now to understand RAG better, let us move to the next topic and revisit the traditional methods used in NLP. First of all, we will be discussing the retrieval based methods, and these methods involve extracting relevant information from a predefined data set or knowledge base in response to a user query. The NLP techniques that form the retrieval based methods are keyword matching, TF-IDF, or semantic similarity to identify and retrieve relevant documents or passages. These are just few examples that I have listed down here, and if you are familiar with NLP, then you must be aware of these techniques. If we talk about similarity, then we have cosine similarity, Jacquard similarity. We also use Levenshtein distance to calculate similarity between two documents or two set of texts. And also TF-IDF here is a short form for term frequency and inverse document frequency, which is used to measure how important a term is within a document relative to a collection of documents. So these techniques form the retrieval based methods which are mostly centered at information retrieval. If we talk about the strengths of such methods, then they excel in providing precise and factual information, making them suitable for tasks requiring accurate answers, and they are efficient in accessing structured data and can quickly retrieve relevant information from large repositories. So providing precise and factual information and the ability to quickly retrieve relevant information are the strengths of retrieval based methods, And if we talk about the limitations, then these methods may struggle with understanding nuanced context or generating responses beyond the scope of the dataset, and they are inherently limited by the information available in the predefined knowledge base and may not adapt well to a new or evolving queries. So again, if in the knowledge base that information which is requested is not present, then such methods fail. This is the major limitation of retrieval based methods. So now we will discuss the second category of traditional NLP methods, which are generation based methods. And these methods, on the other hand, involve generating text based on learned patterns and structures from a corpus of text data. And the NLP tools and techniques that form this category are recurrent neural networks, or RNNs in short. We also have long short-term memory, or LSTMs, or transformer architectures to generate coherent and contextually appropriate responses. And again, as the name suggests, these tools and techniques are centered at generating the text. And not just any kind of generation, but generation of output or response, keeping in mind the context and making the response coherent with the query. So this is what the generation based methods represent. Now if we talk about strengths of such methods, then these methods offer flexibility and creativity, allowing for the generation of diverse and contextually rich responses. And these methods are capable of generating text in natural language, making them suitable for tasks like language translation, text summarization, and creative writing. So these are the major strengths of generation based methods. Now if we talk about limitations, then despite their flexibility, generation based methods may struggle with factual accuracy and can sometimes produce incorrect or irrelevant responses. Now if you want to take for example ChatGPT, then you may have observed that it doesn't always give you the right answer, and this is one of the major limitations of such generation based methods, where they fail to provide factual accuracy in their responses sometimes. And the other limitation is that they also require substantial computational resources for training and inference, limiting their scalability and practicality in some applications. So again, as we know that ChatGPT on the other hand is a large language model, and it requires a very large corpus to train such a model, and for that obviously substantial computational resources are a very big requirement, which not all of us can afford. So these are the two limitations of generation based methods, that they sometimes are not factually accurate, and that training such models requires a substantial amount of computational resources. So we see that in a way these two methods are complementing each other, right? That retrieval based methods are very factually correct almost always, more so than generation based, whereas the generation based methods are contextually more appropriate as compared to retrieval based. So where retrieval fails, the generation comes into play, and vice versa. And RAG combines the strengths of both of these methods. This takes us to our next topic, which is the best of both worlds. And now it must be making sense to you why this topic is named so. So retrieval-augmented generation is built on the principle of seamlessly integrating retrieval-based and generation-based methods to produce accurate and contextually relevant responses. Under this topic, we will take a look at the relationship between traditional NLP methods and RAG, that is how these traditional methods give rise to the RAG mechanism. Under this, we'll first discuss the retrieval side of integration. And in here, RAG uses retrieval-based methods again to fetch relevant information from external knowledge sources, ensuring factual accuracy and providing a strong foundation for the generated response. So, by integrating retrieval, RAG addresses the limitations of generation-based methods regarding factual accuracy and context understanding. Now we just discussed the strengths and limitations of both of these methods, that is retrieval-based and generation-based methods, and we saw that the limitations of these methods is complementary in nature. That is, what retrieval-based methods are lacking, the generation-based methods are having it, right? So in order to overcome the limitations of both of these methods, the strengths of both of these methods have been integrated to give rise to the RAG mechanism. And that is why when we talk about retrieval integration side of things, it is aimed at reducing the limitations of generation-based methods. Because as we know, the major limitation of generation-based methods is that sometimes they can be factually incorrect and give false responses which are not based in truth. So this is the retrieval integration in the RAG. Next, we discuss the generation integration. So after performing retrieval, when we have the relevant information, building upon the retrieved information, RAG employs generation-based methods to craft responses that are contextually relevant and nuanced, overcoming the limitations of retrieval-based methods regarding creativity and adaptability. So again here, now we are discussing about how generation-based methods are trying to cover up the limitations of the retrieval-based methods. So here we know that under the retrieval integration side of things, when the relevant information is extracted from the database, it is word to word exactly the same information which is stored in the database. And when that information is extracted, it is then passed to the generation based methods like RNNs or LSTMs or transformer architectures, where it is worked upon to add context and creativity to the retrieved information to craft a well-formed response. And RAG integrates both methods seamlessly, resulting in responses that combine factual accuracy with contextual relevance and coherence. And RAG ensures that the generated responses are grounded in factual information, enhancing their credibility and reliability. So the final response is not only contextually relevant and coherent, but it is credible and reliable more so than the general LLMs or chatbots or generation based methods responses. So this is what the best of both worlds sums up. We take the best features from both of these methods and combine it together to give rise to RAG. So I hope that by now it is clear what is RAG and the principle behind it. And now we are ready to move to the next topic, which is how does RAG work? So let's break down the working of RAG step by step. We will try to understand the process by means of this flow chart. So here we can see that the first step is the user query. The process begins with the user inputting a query or a question into the system. When the system receives the query, we come to the next step, which is the retrieval phase. Here, RAG retrieves relevant information from various knowledge sources based on the user query. By knowledge sources, we mean the database where relevant information in different formats, be it text, be it audio, be it video, is stored. And this phase ensures that the retrieved information is factual and relevant to the query. And after the retrieval phase, we move to the next step, which is the retrieved information. Now, under this step, the system collects and organizes the retrieved information, which serves as the foundation for generating the response. So here we are preparing the data to be passed to the generation phase, basically. So till here, after receiving the user query, we were in the retrieval phase. Okay, the information was retrieved from the knowledge base or the database, and then in retrieved information, the information was processed and made appropriate to be passed to the generation phase. Then the next step is the generation phase itself, where RAG uses the retrieved information to generate a response that is contextually relevant and informative. And this phase involves using generation based methods to craft the response. After this phase, when the response has been created, we move to the next step, that is the generated response. And here the system generates a coherent response based on the retrieved information and presents it to the user. And the last step is the presented response itself. The generated response is presented to the user, providing them with accurate and contextually informed information based on their initial query. So this is an overview of the RAG mechanisms, how RAG works. Now this RAG mechanism can be used in various scenarios for various use cases. So let's take a practical example to understand this better. So the example centers around a chatbot which is powered by LLM and is utilizing RAG mechanism to produce its response. So we'll try to understand that by the means of this particular diagram. So as we already know that the process starts with a user question, and here the user question is, how many index types does the latest version of Milvus support? Okay, Milvus is a vector database service, and this particular question is aimed at the latest version of Milvus, asking how many index types does it support. So this is the question. Now the question can be anything. The question can be what are the benefits of renewable energy as well. So whatever may be the question, when it is passed to the chatbot in the backend, firstly the retrieval phase begins. Okay, so the first box here shows the retrieval phase. So we retrieve answers to the questions by performing a semantic search using the database. Now here in this particular diagram it is mentioned that the semantic search is being performed by using a vector database, but it can be any database, not necessarily vector database. Although vector databases are much faster as compared to the traditional databases. And we will discuss vector databases in detail in a separate video of its own. So for now, let's just consider it as a database instead of a vector database, although it can be a vector database. Okay, so here we have the retrieval phase. We are matching the query with the database. Okay, so here the database is storing different kind of files. You can see PDFs are there, documents is there, images there. Okay, even it can be audio files as well. If it is a vector database, it can support quite a lot of types of files, and even a traditional database can do that as well. It's just that the format in which the particular files are stored in the traditional and the vector database is quite different, although they are both the databases. Okay, so in the retrieval phase, the user query is matched against the database and all the relevant information is extracted from the database and is passed to the next phase, that is the augmentation. Okay, so here we prepare the prompt for the LLM and question with context generated from semantic search. So here what we are doing, the user posted a query, the query is here, the query is matched with the data in the database and we retrieve the relevant data. Now we have both the query and the data and we are passing it to the prompt. okay, the prompt that has been set for the particular LLM as they work on prompts, right? So here we add additional context to the prompt, as you can see in this particular box. That user question from here is added to the prompt, and the retrieved documents as well. Okay, all the relevant documents that we could find in the database are selected, or maybe we can say the top n retrieved documents are passed to this augmentation stage, and then it is passed to the LLM. The LLM reads all of these documents, okay, it consults these documents, follows the prompts and the user question, and we reach the generation phase. So here again it receives the instructions prompt plus context to generate the answer, and links for citation purposes can be added as well. As we already know, with ChatGPT also we can get the links for citations and references as well. So but as a whole it is a generation based process, and the response that is being created in the generation phase is enhancing the factual data that has been retrieved from the database. Okay, so there is an amalgamation of both the fact and the context, making it a coherent response that is presented to the user in the last step, which is a reliable answer. And if we go by this particular diagrams question, then as of last month, Milbus supports 11 index types. So it is very specific, and we can be reassured that this particular response is factual in nature. That is, it is not going to deviate. So you see now this particular LLM, you can say, is fine-tuned to this particular service. Okay, so now we can say that all the questions that are being answered by this particular chatbot are factually correct, are going to be factually correct, more so than a general LLM. Okay, so this is what RAG brings to the table. So I hope that you are able to make sense of the RAG mechanism by means of this example. So now we can say that we properly understand what retrieval augmented generation is and how it works and what are the principles behind it. And we have also taken a look at one example, understand this mechanism better and how it enhances the result of any chatbot or a large language model. And now we will take a look at the advantages of RAG. So the first advantage of RAG is improved accuracy. Obviously, by using retrieval-based methods, RAG ensures that responses are grounded in factual information retrieved from reliable sources. This significantly reduces the chances of generating incorrect or misleading information, which is a common limitation in purely generation-based methods. So this is one of the advantages of RAG. The next advantage is enhanced contextual relevance. This stems from the generation-based integration side of things, and the integration of retrieved information into the generation process allows RAG to produce responses that are not only accurate but also contextually appropriate and coherent. This enhances the system's ability to understand and maintain context over longer interactions. The next advantage is flexibility and adaptability. RAG can be applied across various domains and types of queries, making it a versatile tool for different applications such as customer support, content creation, etc. The system can adapt to different knowledge bases and data sets, providing relevant information regardless of the domain, given that there is enough data, right? So the better the data, the better would be the response. So this is flexibility and adaptability, that it is not specific to any particular use case. If you have the data relevant to that particular use case, then you can create a RAG mechanism for that in your chatbots, obviously. Then the next advantage is reduced training data dependency. So unlike traditional generation models that require extensive training data, RAG can utilize external knowledge sources to augment its responses. This reduces the dependency on large amounts of training data and allows the system to generate high quality responses with less extensive training. It means that, for example, let's take an LLM. Let's take ChatGPT. It is trained on such a large corpus and it is not specifically created for any particular use case. Okay, so again, it can at times be, inaccurate in its responses. And if we integrate RAG along with it, then even though the particular use case for which the RAG is being implemented along with the LLM, even if that particular LLM did not have, a substantial amount of data in the corpus on which it was trained, corresponding to the particular use case for which this system along with RAG and LLM is being used, even then it would perform better. Why so? Because again, we are retrieving the relevant information. So we don't really need the information to be present there in the corpus itself in a significant amount. It's just that the LLM should be, good at generalizing the generation process. That's it. So again, it's the same. We take like each is complementing the limitation of the other. Right, retrieval based and generation based methods. So this is a perfect example of this. It's just like fine tuning your LLM, but making it factually correct at the same time as well. Then the next advantage is improved responsiveness. So the retrieval component allows RAG to quickly fetch relevant information, improving the overall responsiveness of the system. This efficiency is particularly beneficial in applications requiring real-time or near real-time responses such as virtual assistants and chatbots. And then another advantage is enhanced user experience. By combining the strengths of retrieval and generation, RAG provides users with responses that are both informative and engaging. So this leads to a better user experience as users receive accurate, contextually relevant, and well-articulated information. So these are some of the advantages of the RAG mechanism. And now we will take a look at its limitations. So the first limitation is computational complexity, as we have discussed when we were discussing the limitations of generation based methods. RAG requires significant computational resources for the generation phase. The need for powerful hardware and extensive processing capabilities can make RAG implementations costly and less accessible for smaller organizations. But I would say that it is not necessarily a limitation as of now, because there are a lot of lightweight LLMs also that are available and don't require a significant computational resource as well. So for smaller and specific use cases, we can use the lighter versions of the LLMs or generation based models and integrate it with the retrieval based methods to make it work. So now we come to the next limitation, which is dependency on knowledge bases. So the effectiveness of RAG heavily depends on the quality and comprehensiveness of the external knowledge bases used for retrieval. Yeah, because here we are directly retrieving the information from the database, so it becomes very necessary that the information that is stored in the database in first place is correct. Okay, incomplete or biased data sets can lead to incomplete or biased responses, affecting the overall reliability of the system. So it is highly dependent on the knowledge base or the database in which the information, because of the retrieval aspect of it. Then the next limitation is integration complexity. So integrating retrieval and generation components into a seamless workflow can be technically challenging for complete beginners or if you are not a developer. All right. And this complexity requires specialized knowledge and expertise, making the development and maintenance of RAG systems more demanding. So this limitation, I would say, is not of the RAG but of the people who are going to be implementing and maintaining RAG, right? So obviously people would need to invest more in educating and skilling themselves so that they are able to tackle the integration of the retrieval and generation component to develop a RAG system. But then again, I would say that this is also a superficial limitation of the mechanism, because obviously it is already in use, and with each passing day people are becoming more aware and educated on such systems and their implementation. So the next limitation is handling ambiguity and vagueness. RAG may struggle with ambiguous or vague queries that do not have clear retrieval targets. The system needs sophisticated disambiguation strategies to accurately interpret and respond to such queries. So again, as we have already discussed in the limitations of retrieval-based methods, like if the retrieval-based system is not able to match the query against the database, then we can say that we have a problem. So again, in order to combat such an issue, a sophisticated disambiguation strategy needs to be in place, and this also can be tackled by educating the users while using such a system which is based on RAG, right? So this is one of the limitations. Then the next limitation is scalability concerns. So again, as the size of the external knowledge base grows, the retrieval phase can become more resource intensive, potentially affecting scalability. Efficiently scaling both retrieval and generation process is essential to handle large volumes of data and queries, and stemming from this is our next limitation, which is latency issues. Now the dual phase process can introduce latency, making real-time applications challenging. Considering the scenario that the database which we are querying is very large. So in the retrieval phase, if the database is having a lot of data and we need to match the query against all of the instances in the database, then you can imagine that as the database grows, so would the time of matching the query against the data would grow as well, right? So this can bring in latency issues, and optimizing the balance between retrieval accuracy and generation speed is crucial to minimize response times. Obviously, if in the retrieval stage we are performing semantic search, then some amount of time is to be given to that also, like that time of performing the semantic match of the user query against the data is also to be considered, right? And if it is a traditional database, then obviously the time would increase as the data would increase, the time of processing, I mean. And but these days we have vector databases, which is greatly reducing this limitation. And obviously discussing the vector databases is not in scope of this video, and we will be touching it, and we will be taking it up in a separate video of its own. So so keep a lookout for the video. And here we are done with the limitations
of RAG as well. Okay, some of the limitations that we discussed are somewhat superficial in nature and like not really stemming from the working of RAG itself, like from the RAG system itself, right? But some of it is there, like handling ambiguity and vagueness, scalability concerns, and latency issues. This is something that is stemming from the features or how RAG system works, even dependency on knowledge base as well. Now we will take a look at some of the use cases, particular use cases where RAG can be used. So the first use case is customer support. Here we talk about enhanced automated assistants. So RAG powers advanced chatbots and virtual assistants that provide accurate and contextually relevant responses to customer inquiries. And we saw that in the example that we discussed earlier, right, in the diagram. And the same way it's going to work in the customer support area as well. It's just that the perspective of using the RAG mechanism is shifting. That's the only thing that is changing. In that example, we were particularly talking about the Milvus vector database. Like the system was designed to query anything regarding that particular service that was being provided, and that's what happens in customer support as well, right? So like be it corresponding, so be it any domain of customer support, if relevant data is there in the knowledge base or in the database, then the same pipeline can be used in this use case as well, and in fact in all the use cases that we are going to discuss now. So the benefit would be it would reduce response time and improve customer satisfaction by delivering precise information. For example, a telecom company uses a RAG-based chatbot to handle complex customer queries about service plans, technical issues, and billing inquiries, retrieving information from an extensive internal knowledge base. So this is one of the example where RAG can be used in customer support systems as well. The next use case is healthcare and medical research. So here it deals with information retrieval and synthesis majorly. RAG aids healthcare professionals by retrieving and summarizing relevant medical research, patient records, and clinical guidelines. And it enhances decision making by providing decision making by providing access to the latest medical information and research findings, given that it is being maintained in a database. For example, let's say a healthcare provider uses RAG to assist doctors in diagnosing rare diseases by retrieving relevant case studies and medical literature from vast medical databases. So this is a way in which RAG can be utilized. This is one of the ways actually in which RAG can be utilized in healthcare and medical research. The list of examples is inexhaustive. Then the next use case is academic research and education. And it majorly deals with facilitating research. RAG supports researchers and students by retrieving relevant academic papers, books, and articles and generating summaries or explanations. So utilizing RAG accelerates the research process and enhances learning by providing quick access to vast academic resources. If we consider an example for this case, let's say an educational platform uses RAG to help students with homework by retrieving relevant information from textbooks and academic journals and generating detailed explanations for it. So again, in the retrieval phase, the relevant information from their textbooks. So again, in retrieval phase, the relevant information from their textbooks would be retrieved, and then an explanation would be generated around it. Okay, and this reduces the chances of error in producing the result, ensuring the platform and the students that they get accurate responses. Then the next use case is legal and regulatory compliance. And here RAG would deal with assisting legal research. We all know that there are so many rules and regulations that needs to be taken in consideration while passing a judgment or in the courtroom, right? And this task can be really extensive in nature. RAG assists legal professionals by retrieving pertinent case laws, statutes, and legal documents and generating comprehensive summaries for them. This would greatly reduce the time and effort the legal professionals would otherwise need to spend in researching all the legal documents in order to retrieve information. So it would improve the efficiency and accuracy of legal research, ensuring compliance with current laws and regulations. And for example, a law firm uses RAG to prepare for cases by retrieving relevant legal precedents and summarizing complex legal documents. So this is one of the scenarios in which, this is an example in which RAG can help in legal and regulatory compliance. Then the next use case is content creation and management. And here RAG deals with generating informative content. So RAG helps in generating high quality contents for blogs, articles, reports, and social media by retrieving relevant information and crafting well-informed narratives. It saves time and effort in content creation while ensuring factual accuracy and contextual relevance. For example, a news organization uses RAG to generate comprehensive articles on breaking news events by retrieving information from various news sources and databases. So this is how RAG can find its use in content creation and management. And these were some of the use cases in which RAG can be used to enhance the response for the targeted user. The future of RAG looks promising with ongoing research and advancements. As computational power increases and retrieval methods improve, we can expect RAG to become more efficient and widely adopted in various AI applications. In conclusion, Retrieval-Augmented Generation is a powerful approach in NLP that combines the strength of retrieval and generation methods to produce accurate and contextually relevant responses. Despite its challenges, the potential applications and benefits of RAG make it a significant development in the field of AI. And I would like to thank you for joining us on this deep dive into Retrieval-Augmented Generation or RAG. We hope you now have a comprehensive understanding of how RAG works, its advantages, limitations, and its wide range of real-life applications. If you are excited about the potential of RAG and are considering implementing it in your projects, whether for customer support, healthcare, or any other domain, we are here to help. At Codersarts, our team of experts specializes in advanced AI and NLP solutions, including RAG and similar technologies. We can assist you in designing, developing, and deploying customized RAG-based systems tailored to your specific needs. So don't hesitate to reach out to us. You can visit our website at www.codersarts.com, or you can reach out to us via email at contact@codersarts.com for inquiries and consultations. You can also follow us on our social media channels for the latest updates and AI insights. Don't forget to like this video, share it with your network, and subscribe to our channel for more insightful content on AI, machine learning, and natural language processing. Thank you for watching, and we look forward to helping you bring your AI projects to life with the power of RAG.